Or it could be just two different classes, like, if you're trying to detect genders, let's say, based on some characteristics, or you're trying to just differentiate from two different classes. So that can be a type of binary classifier. But on top of that, you're saying that it's specific for logistic regression. And when we're talking about logistic regressions, the first thing that pops into my mind is probabilities, right? You're basically assigning a probability of whether your unknown object belongs to one class or the other, right? So when you hear logistic regression, you should always be hearing about values between 0 and 1. That's kind of one of the main differences between standard regression and logistic regression, right? The logistic regression is going to be a value between 0 and 1, whereas a standard regression analysis can be any number of values, based on what you're classifying. Or it could be some sort of a multi-class also. So the added complication there for the logistic regression is that when you have the result to your model, you have to put it through an additional layer to give you that value, that probabilistic value between 0 and 1, right? So that's kind of the difference there, where you don't care necessarily about what the straight answer is from the model. That really won't mean a lot to you. What matters is you putting it through the logistic formulas at the very end, so you can get to those values that give you the probability of belonging to one class or the other, right? And then from there, in addition to that, you might need to set a threshold to say, well, I'm only interested in classifying it in one class if the logistic value is greater than, say, 0.75. There's no magic to that number. That's not a standard or anything. I'm just using that as an example. But that's kind of the differentiator between your classic regression problem versus a logistic regression problem, right? So